Right, the first two talks are really scene setters, and I've got a brief to have a look at the physical scene that is occurring around Scotland's coasts. So what's happening at our coasts is where we're going. And the first thing to say is that we're not alone. The world's coasts are eroding. About 70% of the world's coasts are eroding at about 0.5 metre a year. The world's sandy coasts are thereabouts. So the question is, what are the drivers of those various types of erosion and flooding? Well, there's clearly sea level rise, which is increasing. There's enhanced storm impact, which is clearly increasing. I think last winter has shown us that. We've got a reduced sediment supply, which maybe most people will find quite surprising. And we've got increased management. And I've put management in inverted commas because there's a lot of evidence to suggest that we're not managing our coast very sensibly at all. So I want to simply unpick each of these in the 8 minutes that I've got. Sea level. Is sea level an issue? Well, historically, it's always been increasing, about 1 to 1.5 millimetres per year, historically, is the rate. If you, however, have a look at the most recent rates, and we've got those because we've got a junkyard of satellites flying around the Earth just now, giving us altimetry, you can see that that rate has increased quite substantially, something around 3.2 millimetres per year. It's what the global sea level rate is rising just now. And that's not just from NOAA. There's a whole range of various organisations that agree that that's the rate of sea level rise. And that's a problem because that, of course, delivers the water at a different level. I suppose we are really interested in how this affects Britain. And what you see here are IPCC predictions of what sea level might be doing to the UK across a whole series of time steps. The 2020s, 2050s, and 2080s are thereabouts. And what you see is a variety of different scenarios. The worst scenario is high emissions. If we continue with our high emissions scenario, then in about 100 years or thereabouts, we will have up to 0.7 of a metre sea level rise in the south of England, slightly less in central Scotland, and slightly more in northern Scotland. And that's a function of isostatic recovery, the different rates here. Of course, the rates are much lower if we go for a low emissions scenario. So the question, I guess, is, are we on track for a low emission scenario or a high emission scenario? One way of looking at this is to have a look at tide gauges. And this is a map of the tide gauges in Scotland across something like 100 years, just over 100 years. And what you see are relatively low rates. The low rates in the centre of Scotland are clearly the effect of isostatic recovery, which is greatest in the centre of Scotland, and it declines away from that. So it declines towards the south of England, and sea level rise are faster there. It also declines out towards the Outer Isles and into Shetland and Orkney to some extent. If you then compress that data and have a look at a map that takes tide gauges from 1992 to date, then there's a different scenario altogether. That is that the rates of sea level rise are not exceeding isostatic recovery in any part of Scotland, even the centre. So the myth that isostatic recovery is going to keep us safe from sea level rise is just that, it's a myth. And since about 1990, or perhaps slightly earlier, sea level in Scotland now outpaces land uplift. So we have a problem in terms of sea level rise in Scotland, is the general idea. We can talk about health warnings about how rapid that rate is going to be, but we've got a problem. So sea level rise is an issue. The other driver, or another driver, would be storminess. And you'll hear a lot about storminess. Are we having increasing storms? There's no real evidence that our storm rate is increasing. What there is evidence of is wave activity increasing. That is, the storms that we are getting are more severe. And that's a problem because we are in a relatively high energy environment. If you looked at the data from Schiehallion, which is the oil collection platform just to the west of Shetland, then the annual maximum wave is 28 metres high. 20-metre waves that exceeded 100 times a year at Schiehallion. That's why Schiehallion's bows have been redesigned 3 times in the 10 years it's been in place. And the new one is under construction because the old one's knackered. So we've got a problem. The highest wave ever recorded on Earth is 29.1 off of Rockall So we are in a high energy wave environment, and it looks as though those winter wave heights are increasing year on year. Not so many storms, but the storms we're getting are more severe and more deep, and therefore the wave activity is increasing. Is that a pattern? Well, the answer is yes, because if you look at the Northeast Atlantic, Northwest Atlantic, and merge that information, then what you tend to find are year-on-year rates of increase of the maximum waves. This slide shows HS, which is the highest third of all waves. If we went for maximum waves, the rate would be higher. This very difficult to estimate maximum waves because they're intermittent, but you can see a year-on-year increase in wave heights. So wave heights are a problem. Storminess is not a problem. Maximum wave heights are, and they're the ones that do the damage on an elevated sea level. Is that all tricky? Right, what about sediment supply? Is sediment supply an issue? Well, yes, because we're now well into an interglacial. Sediment from our rivers is slowing down. We've got very little sediment in our rivers. Sediment supply from offshore has gone, and that means that erosion begins to kick in because we don't have the same amount of sediment protecting our shoreline. That's one of the reasons why we know Skara Brae is where it is. It was actually built behind a dune system in the lagoon. They've gone. Is that a problem across Scotland? Well, yes. I could produce this sort of slide for almost every beach. What you find there is a landward movement of high water mark. That's the blue. That's coastal erosion. But what you also see is a red movement, which is twice the rate of low water mark. That's a bit you can't see. So low water mark is moving landwards faster than high water mark, so shorelines are steepening, sediment's running out. And those are the differences. Height changes and volume losses across Scotland's coasts. So what do we do about that? Well, the answer is we react by either physically controlling the processes via seawalls, revetments and groins, or we zone to adapt to accommodate processes. We can begin to relocate assets and infrastructure. That's perhaps the clever way to do it, because throwing money at seawalls, rebuilding seawalls ad infinitum, may well not be a viable solution, certainly not in areas that are low real estate. We'll only be doing it for the Grangemounts. We'll only be doing it for the Leiths. We'll not be doing it for Brora, for example. We clearly can't do it very well for Gulf's Peak either, as you can see there. There's a hooter about to sound. So what do we do? And this is the second last slide. There are key obstacles. Key obstacle one is there's a false assumption that the magnitude of future change can be accommodated with the present confines of where we think the coast is. That's a big problem. That's a mindset problem, a Canute problem. Key obstacle two is that strategies that fix the coastline where it is are really unsustainable, and what we really should be doing is allowing shifts. And those shifts are all about adaptation. We've got time in Scotland. We're not as serious as the south of England. We've got some time. We should be fixing the roof while the sun shines. We need to be thinking about adaptation to give us time and space to accommodate what will be happening in the future. That's me finished. Thank you.